All right, welcome back to another edition of the Houdini stream. So today, Saturday, we're going to be moving on from the fractal projects that we've been doing the last couple of days. So we were just generating these using Vex, creating particles, and then rendering them with Redshift. So these were some that I was just playing around with last night, generating them using the same techniques that we were going over. But we'll be moving on from this today and covering something else. I just wanted to show these so you guys could take a look. And then also on the same topic of the fractals, I have some unfortunate news. So it looks like if you guys ever had the Intel processor, La Cuckoo, how's it going? Yeah, music. You want music for DOPS? Bring back the beats. So the Intel corporation, if you guys ever had these processors, they discontinued the dodecahedron packaging, unfortunately, today, which I saw in my news feed and was disappointed about, but it reminded me about the base shapes or whatever, because we were using that platonic solids to generate some of these fractal shapes. So with the conclusion of the fractal creation stream is also RIP to the Intel. This is some of the greatest packaging of all time to me. It's like, so you bring that home to the wife and kids. Imagine how pumped they are. So today, whoops, leaked all my emails. So today, we're going to be moving on to something new, which will be like a shockwave. We're going to be setting up this kind of dust simulation thing. So this kind of pyro technique, but we're going to be spending some time building things out before we jump right into pyro and do all that stuff. So generally, I try to use particles when I'm working with DOPS, when I'm working with smoke simulations in general. So to sculpt or to construct forces, like if you have an explosion, I find it a lot easier to model. That wasn't exactly what I was talking about, but model like a point cloud or a particle simulation that's behaving in the way that you want your smoke to follow, and then it's a lot easier to control things and like iterate faster, essentially. And then the place or the reason that I do that is I'd been working at ILM a few years ago, and they have a custom GPU solver. I don't know if they still have it, but they've done presentations on it and stuff like that. So they have their own smoke solver that runs on the GPU, kind of like the stuff that I was setting up with OpenCL. But they will always work using a similar fashion or some similar workflow. This actually might not be the video I'm thinking of. So there's a different one it might be. There's a video that's like more of a presentation that I've seen before, but you can find other pictures and stuff like that. So they'll generally make a particle simulation just to sculpt or to design the forces that they want to basically see behave as smoke or fire. So it's just a lot easier and more art directable, quicker to set up or quicker to see what's going on. It seems like generally in the past, a lot of Houdini simulations, people set them up using what's like volume noise or volume velocities. And those are they take a lot longer to create because you're filling like a 3D volume with values instead of just creating a sparse set of particles. So this is why it's just the reasoning or whatever. That's why I tend to work that way. And then for the Shockwave, instead of just doing a kind of generic looking thing, I'm planning to try to set it up going over terrain. And then I want to try something like, I don't want to just make what everyone else is making here. So I want to try to separate it a little bit and make something that's going over a terrain or mountains or something like that. So you see the Shockwave like avoiding hills, moving around things and stuff like that a little bit. So it's just something that's a little bit different. It might not be, the end result might not be something entirely grounded in reality. It could be something more abstract. So let me see if I have any more kind of references or stuff like that. Usually I'll look on Vimeo. This is a good, seems like it's getting used less and less just because I don't know, the younger generation is abandoning it. Seems like YouTube is getting used more and more for visual effects, even though that wasn't generally the case. Like, seemed like 5 years ago, YouTube's quality was pretty poor, that people didn't use it to upload demo reels and stuff like that. But in the past 2 or 3 years, it just seems like people are sharing their portfolio work or stuff like that on there a little bit more. So I'm just going through some of the videos that I've selected with my likes or whatever. So we might do maybe some abstract kind of fluid that's running through the Shockwave or something like that. So that's what I mean just by it might not be physically kind of grounded in reality. So we'll go ahead and get started. It was just something that I was playing around with or whatever. Get rid of that. Yeah, it seems like they're just in recent years, Vimeo, they've basically just had a bad business model, or maybe management or something like that. But yeah, they're plus subscription stuff. All of their, I don't know, just their entire way that they're marketing themselves, and then just trying to like navigate and find relevant videos. It's become very frustrating. They used to be like, maybe even 10 years ago, they used to be like the leader in terms of just video quality. Every like indie filmmaker would use it, but I don't know. Even their rental service kind of subscription thing or whatever that they tried to debut. So we'll get started with, you think it's a net neutrality type thing? They don't have the bandwidth. So we get started and just make a terrain, like a base kind of ground form or shape or something like that. And then usually I'll start with the shelf tools if I can, just to, I don't know, I don't use them all the time. Like I generally don't use a shelf tool after I've started with an idea, but to get a file started, if like as a starting point or just to save time, sometimes I'll use the shelf tools. And I've set these up just to display as text. So I have more room for the user interface. The viewport can take up more space or whatever. So that's why they might look a little bit different than yours. So we'll do the hills kind of starting point. So I'm going to be making a Shockwave. So I want this stuff to start in the center. So I'm going to try to clear out or just move the noises around until I can get more of a gap or something like that. But this is nice, but it's just a little bit too linear, just in one direction. Just terrains is, I don't know, these noises are kind of weird. It's like they make your starting size so big that your offsets need to be super high numbers to jump around. So something, I'm just trying to get something kind of like this, where there's some valleys in the middle of my ground section, because that's going to be kind of the starting point of my outward force. So I don't want to start it like on the top of a hill, because I want everything to kind of be going up and outwards. Let's just see if we can get some more possibilities. So this could be a cool idea if it's like a more of an X shape somewhat. All right, let's start to try to select something. It's easy to spend doing effects, working with Houdini. It's easy to spend your entire day shifting noise patterns around. I remember one time I was working with a guy, and he had the ergonomics person come by his desk to try to help him find like a more streamlined posture setup or situation. And the person asked if he was using the keyboard or the mouse, or what instrument he was spending most of his time using. And he just said, well, generally my day revolves around typing in different number values. He just spends his whole day trying different, typing in different numbers. I feel like we were at a better, we were out of something that was pretty good. I'm trying to find, like, if this is a river or something like that, I'm trying to basically not have like a single inflow or outflow, but if that makes sense. So like I want multiple paths kind of leading in and out from the center. I think if I was smarter or more I don't know what the word is, but more efficient of working, like there's ways to paint a mask or to paint curves and use those to create rivers or valleys and stuff like that in your terrain. So if you wanted to work maybe a little bit more like art directable, or I don't know, user friendly, that would be one way to do it, is you could paint areas that you wanted to fall down basically. All right, this one is pretty cool. And then with my roughness here, I can make just everything a little bit kind of more detailed, more of a mountainous, I don't know, rockier terrain, I guess. And this visualization stuff, I don't think you have to worry too much about it for what we'll be doing. But basically that's just their elevation visualization stuff. And then the way that their erosion works, this is set up as a simulation. I think it will by default use some OpenCL stuff, so like your graphics card will speed it up. But just be certain that you have to move the time slider around or whatever to initialize or to advance in the simulation. and that will basically add some kind of river stuff going down like that. And you can also just convert the height field, and that will get rid of the visualizations. So then you can kind of see what this erosion model is doing. So it's basically pretending that there's water at the tops of these hills and running some noises or algorithms to like deform the mountains or whatever as everything flows downhill. It's a little intimidating to me. Like I wish that, I don't know, like there's too many parameters. Maybe it's too makes me afraid to jump in and start adjusting things. Like if I just wanted to make these rivers have a wider occupy a wider space, I'm not really sure what the best way is to do that. And then this stuff over here is definitely pretty intimidating. Maybe it's this water flow. I don't know. I don't think it matters too much for what I'm going to use this stuff for. It will take some time to run each time. And then just for overall detail, if you go to where the height field is initialized, the grid spacing, this is kind of like your smoke object, or if you work in DOPS, like division size. So as you reduce this, the grid spacing, or basically the resolution, like the division size, will go down, which causes the resolution to increase. So I think something like 0.5 at this resolution ends up being maybe like 2K or 4K, 2K. So all of these height fields are actually just volumes inside of Houdini, but they're like two-dimensional volumes. So it's kind of like the same thing as an image. You imagine an image just an array of pixels or voxels, just in 2 dimensions. And so this is like 2K by 2K texture map. And then the value for visualization purposes gets used to choose how high the terrain will be. So something like this, I think, could work pretty well for what we're going to do. So I'm planning to start things in the center and have everything spreading outwards. The main reason for this height field is just to have some interesting collisions or characteristics for things to rub up against as everything pushes outwards. And then if you don't like to work usually at such a high resolution, or I'm sorry, not resolution, but size, like this is 100 units in X and Z. If you also use this test geometry Tommy, this way you can see, like, if you're used to working at a certain scale, and then like we're a lot bigger than we typically make things in Houdini, I guess. This is actually more of like a physically real world scale, but if you're just used to working with smaller numbers or whatever, one of the things that I'll do usually is transform the height field. So we could go to 0.01, so that's like 1% or 1/100th of the scale. And now we're back to 10 by 10. So if you usually make a grid in Houdini, the default is 10 by 10. So we're scaling our height field down by that. But you'll notice the actual height values didn't get compensated, or the scaling operation didn't get applied to them. So if we just do a height field wrangle and plug that in, then we just do f at height. I don't think you need the f. It's basically saying that it's going to be a float field that we're operating on. And then if we just multiply that, we can make a new channel that will be scale. So instead of times, I just need to do times equals. So now you can see that we have a slider here, and we can scale the height value. So all of these are different volumes. We have some masks, but the main field, or the main thing that we look at in the viewport, is height. So if we scale those values, we just change the overall like elevation amount. Then I can just copy and paste the relative references. And now you'll see that we have shrunk everything down uniformly in all directions. And then I'll just usually do a file cache. Because this stuff is a simulation, here you'll notice it's adding this little icon that's like a picture of a clock. If you don't see that, you press the D key, and you can choose which badges or which icons to show. But you can see that this clock basically means it's a time-dependent node. So basically that means every time you change the frame, it will require this node to recook, which can cause your scene to slow down. So you're asking if the height field transforms up? It's possible. I've never I've never noticed that one. Let me see. Let's give this a try. Ooh, I think you're right. So you saved me some steps there. So that's one of the problems I have with Houdini sometimes, is that they make it so easy for you to work around, or there's like 20 different ways to do something. So sometimes the easiest or most obvious, most simple way isn't the most obvious. So thank you, Erdhardias. So we'll go to cache this. So I just don't want it to be time dependent anymore. So it will be a current frame. We don't need the $F4. I'm just going to put this in the temporary directory. Usually when I put the hip files and stuff online, I don't distribute all the geometry and stuff like that. So you just have to regenerate this. Thank you, Kieran. Yeah, I guess I saw on Twitter Mr. Matt Estella, CG Wiki. He gave me a very nice endorsement or plug. So hopefully we have some new people here. Hopefully they like what I'm doing with these live streams. So this will just be terrain, height, field, and everything should be good. So you can see once I've cached this out to disk, we no longer see that clock, and I can move like this thing around and nothing has to update. So this is just part of like keeping your node tree somewhat optimized or running cleanly, running quickly, I guess. And then I have a couple different ideas for how to start to model this outward force direction, these outward particles. We'll just start with a pop net. So I'll plug my height field into this auxiliary input. And then the way that this gets initialized, whatever's in this first input, is typically used or just set up by default to use for the emission source of the particles. So I'll do a circle. This is kind of what I meant when why I do the height field scale to shrink it down. I do this just so when I'm making my other shapes and my particle forces and all that stuff, like everything else in Houdini is kind of set up to work at a smaller scale. So I'll make a circle, and then by default it's making this, setting it up as a primitive. So I'll just do remesh. This will convert the single primitive or like circle type to polygons or to faces. And then we can, I might have skipped something. So I guess I actually have to do a convert first to go from the like circle type to polygons type. And then my remesh, I can up or lower the division density. And then what I can do is use this ray node. It's pretty useful. It does, I'm going to be using it pretty much what the icon does. So I can plug my height field into this input, and it will just try to project the circle onto that shape. So, and it does it based on the direction from the normal. You can reverse it, or sometimes if there's still problems or artifacts like that, you could switch it from projection to minimum distance. So that will just disregard the normal and just snap it to the nearest position that it finds on the second input. Sometimes I'll turn off the guide geometry, and maybe I'm going to go back to projection and then just reduce the resolution a little bit, and it looks like that's a better way to get rid of the artifact, but we can still preserve like the circular silhouette. I haven't tried it, but it's possible that we can project, looks like we can project directly onto height fields. So that's nice. We don't need this guy. So I didn't realize it, but this is a good feature of Houdini that you can, it's useful. We'll go into our PopNet. If we play our simulation, nothing happens. Ooh. But so we don't have any forces, we don't have any colliders. That's why we're just getting a boring thing. But our emission is working, which is good. The one thing I do want to change is just not to have constant activation. So I can turn that off, just set that to 0. Even though, for whatever reason in Houdini, they set these up as like float sliders, but these are basically just toggles. Like you would only really want to set this to 0 or 1. And then I can just use an expression here. So if you do $SF, that's basically the simulation frame. And that will always start at 1, like for the first frame of the simulation. So that's why it's different than floating frame or like $F. So if we check if that's equal to 1, so we just do these 2 equal signs to do a comparison operation, then on the start of the simulation, you can see that set to 1. So that's just a quick way to basically say only create or only source, only emit particles at the start of the simulation and never again. You could do it with a keyframe or stuff like that, but generally it seems like Houdini people prefer to avoid keyframes whenever they can. So now we're just creating our particles on the start of the simulation. So maybe we want to do a force. So if I go up to my input geometry what I can do is add velocity to this shape, and then the particles will inherit that velocity, and that will give them like initial momentum for the simulation. So one kind of hacky way or whatever, or like maybe it might be a hack, it might be more of a cheat code, but something I usually do is I'll do a wrangle and I'll plug in a transform into the second input. You could template that if you want, and then I'll just use different scaling or translation operations. And then you can do the vector at v. So this is saying the velocity vector, and make it equal to, and then the at symbol at op input 1 underscore p. So let me see if that works. So it looks like that works. So what this is saying is to just grab the point position from this input, and then I usually subtract from at p, or the point position from this input. And let me just double check everything's pointing in the right direction. So these, you could also, so the way that this is, yeah, I think that's working correctly. So this is looking at the difference between the point here and the point here. And then kind of like if you're picturing like a slingshot, yeah, you could see the specs and links and everything like that in my Twitch panels. There's also, I need to get my bots set up. So like you should be able, at some point, if you could do that, commands, like I could do exclamation point specs and start up, but I'll just have to do that later. So what I'm doing here is just setting, basically, my current point position will be aimed at these points that I'm scaling or shifting around. But instead of moving them there, I'm adding a velocity vector that will say, like, try to move the points in this direction. So if we look at our simulation, we can see they're already starting to go in those directions. And if I play things, it's moving. So that's what this guy does, or that's why I set it up this way. It's like, I don't know, it's a nice effects trick, basically. You have a lot of control to quickly visualize your vectors. You want things going higher. If I want to just have things like outwards, but not changing like elevation that much, then I can do that kind of thing. You'll notice, like, because my source shape isn't flat, there's like some weird intersection interference happening. So if you really want to, you can also multiply the vector by like a parameter or a scale. So if I just make a another vector here, basically I'm saying allow velocities in the x component, allow velocities in the z component, but don't, or eliminate, delete any velocities that are happening in the y. So it will just zero out any velocities. You can see everything is now just only moving horizontally. Sometimes, like, you could see maybe the DOP simulation for a second didn't update. If you want to, sometimes there's bugs or problems with Houdini, like these results are out of date. There's another kind of cheat code that if you just hold down the control button and click on this brain, it will clear all of your simulation caches. So that's a lot easier than like if you're working in here and you're changing parameters. Sometimes you just want to be sure that the cache or the results are fleshed out. So now we have our guys, they're all moving outwards. We have a nice quick control, an easy way to change that. So now we just need to set up some collisions or maybe additional forces if we want. So if we grab the terrain, there's actually a new object or somewhat new object in DOPS called the terrain object. And this is nice because it can directly read in height fields. So this data here is a height field volume. So we can directly use that as collisions without needing to invert that. In the past, it was always kind of a pain to represent ground, like deformed ground planes or whatever in DOPS, but this is a pretty nice addition. And then I usually just make sure, so these are always set to left, affects right input. So right now, it won't have any effect on my particles. So you just want to be sure to, you click this arrow here, and that will change the wire. You can also change this to mutual or whatever, but usually I just leave things set up this way. And then we just need to make sure we're grabbing the additional input. So we wired it into this index. So index 0, 1, 2, 3, whenever you're referring to them with expressions and stuff. So I can do up input path. And then you just give it the input name, the name of the path, and then the index number. So the node, I just want to do the 2 dots basically to go up a level, and then do 1. So if I middle mouse button on that to evaluate it, now you can see it's procedurally or like script-wise or programmatically grabbing that input. So this is just saying to go up a directory, like if you're using a file system or something like that. Oh man, I lost my chat. Something happened. All right, I think we're good. So, so this is just saying to go up a directory, and then we have input 1, which I was saying index 0. So these numbers at the bottom of the screen are a little bit misleading. And then for collisions here, I think we're good. And then the reason why we just don't see anything in our viewport right now is because my display mode is set to wireframe. So if I go to smooth shaded, now we see my collision geometry is in here. I don't know how something happened. All right, we're good. Maybe that was a viewport error or something like that. Everything is crashing. So we could just play things. You could see that we're getting bounces or like deflections, collisions and stuff like that now. But we don't have any gravity. This is like outer space, anti-gravity. So we can just add force. Usually I'd do a pop force instead of gravity. So if you do gravity, those have to go down here, and it's more of like a global simulation force. If you do a pop force, you can choose groups, like subsets of particles. You can use expressions, and you just have a lot more control over this is like a little bit more, you don't have as much control over that gravity. So if you just do negative 9.8, then you have the Earth, Earth-style gravity. I'm just gonna click this flag right here, kind of the teal one. That will just hide my emission source geometry. I can do the same thing with this collision thing if I want to. And then I'm just going to click the clock down here to make sure that my playback is playing back at like 24 frames a second. So hopefully this chat is working. All right, I think I was nervous that maybe it didn't reconnect after it crashed. So we have our gravity. You could see everything was getting pulled. Thank you for the test. So everything was getting pulled down into the middle of our terrain. So I might want to add an additional outward force. We can use these vex expressions. It's a little bit different than the wrangle stuff that I was doing earlier. The main reason that it's different is because you can basically, you use it to modify your parameters. So this force, if I hover over it, I can see it's saying the actual name with a lowercase f. So I can do force plus equals at p. So this will basically take the current point position and try to keep moving things out using the point position. I can scale this up just by multiplying a number by it. Now you can see everything's getting cleared out of there a lot quicker. But the big issue right now is that as the position gets further from the origin, we're applying more and more force, because basically we're getting further, so we're saying this number, the force that we're adding to it gets bigger as well. So I can normalize this, which will basically just say ignore the magnitude of this vector and just treat it as a direction. So it will always be a unit magnitude. Or basically, it won't have it, like the scale of the vector won't have any influence. Does that, hopefully that makes sense to everyone? Saying ignore the scale of the position vector and just treat it as a direction. So whichever direction the position is away from the origin, just keep moving it along that direction. So now we have all of our guys kind of like little skiers. They're going uphill instead of downhill and crashing after they get over the mountains. On this terrain object, if you want, I think with the maybe they don't have a sometimes they have a way that you can override the border setting, because it looks like right now it's basically using like a streak, so it's taking whatever value and extending it. That's why you get like the grid artifacts or whatever, but we don't need to worry about that for what we're doing. We might want to do some drag force on our particles. And then I think what I can do here, somehow we turned all our particles into termites. So that happens because the height field, this has a material detail attribute assigned to it. So it's basically looking for a sprite or something like that to try to apply to these particles. So if I just use an attribute sop, delete the material, then we're back to what we had before. You can also go into this pop network, and under object, instead of the asterisk, this just means retrieve everything from the DOP network. We could just do pop star. So basically that just says objects that begin with pop only import those objects. I can get rid of that template for now. So now this could be my my outward force for kind of the start of a shockwave or something like that. If we want to visualize things a little bit more, we can use this trail. And then you do an add node under that, and do by group, then by attribute, and then if you do ID, basically this will just say only connect the same particle by its ID. So the pop network, it assigns a unique ID number or attribute to all of these particles, so we can use that to connect them or draw lines. So this is a lightweight way, or it's an optimized way of adding trails, I guess. I'll just pin my display up here, and then we can kind of take a look at the different ways that this drag is affecting my results. So without any drag, we have a pretty uniform outward direction. If the more that I increase my drag, and maybe also the more that I increase my gravity force, this might be the issue I was talking about earlier. I'm just going to hold control and click that. Yeah, so you can see my settings weren't updating each time. So we'll go back to 9.8. Yeah, so that's what I was trying to show with the drag. So the more that I increase the drag, as these guys move through the terrain, through the hills and valleys basically, the more that they'll find or flow through essentially like the gutters or the low points, the rivers, or whatever you want to call them. So it doesn't matter too much for what we're doing, but I just wanted to point that out, that this is what is controlling. Actually, I mean, it does matter a good amount, because if we were to make this a shockwave, it will define the overall look and outward force of everything. So if I completely turn off my drag, you can see we have a pretty uniform outward direction. So if I go up to like 1.6, now we start to have some negative space and stuff like that. If I just increase this, then you can get an overall quick kind of look at things. So we go up to 3, just recache. You can see that has that effect. Maybe we'll just do like twice as much gravity roughly. So using these trails, this is a quick way to preview results without having to keep scrubbing the timeline and rerunning simulations and stuff like that. So something like this could be a pretty cool way to do things. I'm just going to decrease it a little bit more. I want them to go to find more areas of the mountains, but not just a completely uniform, like, outward direction. I want to start seeing these guys get, like, pushed aside. I can also reduce my outward force if I want to see what happens here. So something like this, I think, is starting to be pretty cool. You might also want to increase or play around with your substeps here. So I guess you missed it maybe at the start of the stream. Was planning to try to make a kind of shockwave thing like this, but instead of having it happen on a flat ground, I'm planning to try to have it basically move or push outwards through these mountains and get pushed aside. So instead of just doing something that will look like whatever everyone else is doing, kind of, I'm trying to take that idea and just put it in a new kind of context, I guess. And then I was talking a little bit about maybe doing it in more of like a stylized, non-photorealistic manner. So maybe you do it as like a fluid, just moving through like an abstract kind of, this could be like a macro scale kind of thing. Like this could be the surface of a metal, and maybe it's like little mercury fluid. I don't know, it's like it's a potion traveling or infecting something. But this is just the starting point, so that would be more of like a rendering side of thing. So I'm just trying to set up a force through particles that I can start to use to drive a fluid or a smoke simulation. So this is one way we could get started. So I'll just do this. Usually I like to try to stay organized as much as I can with these networks. So if I do end up saving the file and just wanting to reuse a portion of things, it's a lot easier to grab a node tree and pull that in. And then that's also why I'll use these, like, these at op input path expressions whenever possible. Because if I did this to a relative reference, then if I copied and pasted this DOP network into another Houdini file, I'd have to rename like my inputs or reassign things. So that's why I tend to go through and do, it's a little bit more programming or whatever, but like expression typing, but I tend to find that it pays off. So this is one idea. We can also take things and try something else. So instead of using particles, you could see one of the issues is just trying to art direct things. Some guys are getting stuck in some areas, and maybe we don't have as much control as I wanted to. So I'll just try out another idea I had for making this outward radial force, but something that's also moving to the terrain. So I'm going to convert, I think I just want to do a height field convert. Then I can turn off my template up there just to draw things a little bit more cleaner. And then this grid is a pretty high resolution. So if we want to make it less, we could use this remesh node. This should take some time, but it's something that's kind of nice to do. Basically, this might take 1 minute to complete this operation, but spending the time to do that will make all of your further operations or nodes that you add evaluate quicker. So even though it might look like it's a slow thing to do now, it will pay off later. So if we have any new people here, just feel free to put any questions if you have them in the chat. If you're curious about the reasoning why I'm doing things, or if you think I'm missing a node or there's an easier way to do it. So this guy, you can see the percentage at the bottom. It's like 30% done. Maybe my target size is too small, but I think we're good. I'll be right back in a second. It just finished. Yeah, so this takes 1.5 minutes. But if you look at the mesh or just the overall primitives, we went down by a lot. So I'm gonna get some water, but I'll be right back. All right, so we have some other ideas of how to sculpt or create that outward trajectory kind of information. So we can use this find shortest path node. The way this works is you just give it starting and endpoints, and it will try to evaluate or calculate the cost or how easy or hard it is to get to that position on the mesh. So usually I'll just do a sort, and then this will let me order the point numbers by the proximity to a point. So my Shockwave is starting at the origin, so I can just sort all of my points by closest to the origin or proximity to the origin. And this will just make sure that the 0th point number 0, will be at the origin. So if I turn that off, point number 0 might be somewhere on the edge or the border or something like that. So I can just plug that in now, and then for my start point, use 0. And then my end points, I could do exclamation point, exclamation mark, everything except 0. If I want to, I can draw paths, maybe from each to end. And then you could see we have another way of making like outward directing paths. But right now we're having a similar problem that we were having with the this is like our particle simulation without gravity, basically. Like all of these paths can get up the hills just as easily as the ones that are going through valleys. So to fix that, we can make a path cost attribute. So this is basically just like how much resistance or how hard is it for a point to travel across the terrain. So I can just do this one. There's no built-in name for it. You can just call it whatever you want. Usually I'll just do something, maybe resist, because this is like a resistance value. we can set it to the y component of the position. So basically the elevation. I'll just copy that. So now that we're using things in that manner, you can see it changed the result. To make it a little bit more clear, if I just multiply my elevation, now you can see, oops, all right, now you can see it's like harder for these guys to cross over the hills, and they're getting moved in this direction a little bit more. So if I turn this off, you can see the difference that that guy is doing. And then we just have our number here. Maybe I want to turn this into a parameter. So now we just have a slider that we can use to augment the that resistance value. So maybe something like that. So these paths could be something that we could use for forces. We did a polyframe. Then you can use basically the tangent information as velocity. So I can do, maybe if I just scatter. Ooh, it's not what I want. So I think the problem is that there's so many overlapping paths that it's biasing our scattered distribution to all be in certain areas, because there happens to be a lot of paths that are overlapping in that area. So I might abandon this for right now. I'm just going to do another find shortest path. And this one, instead of outputting paths, I'm just going to work with this cost attribute that we're creating. So if you look at the geometry spreadsheet, we have a bunch of information that's getting passed on from this convert height field. And then we have a cost attribute. You can see it does have this little 64. That just means it has higher precision. The new Houdini feature or whatever, we can have attributes. Basically, it just means that it will kind of keep track of more decimals or be able to represent more precise values. So we have this cost number and we could visualize it. So I'm not a big fan of the visualizer nodes in Houdini. I like to usually just work with a wrangle and then the color attribute, or CD, it's like color diffuse. So if I put the cost into it, we could visualize it. So we see we do have some negative numbers, and then the super white values are probably higher numbers, much above 1. So we can also do a sine function on this cost. Now you can see we kind of have something like terrain contours. I could do another remesh. So I'm doing it below the remesh that I did earlier, just to prevent that, because this was a long cook. It took like 1.5 minutes. But if we just do another remesh to increase division size, it will be a little bit quicker. So now you can kind of see what this cost attribute or cost value is giving us in terms of generating almost like you look at a map, it's like elevation. Basically, these things are trying to move in other directions than across that stuff. So you can see changing that. I'm just scaling the resistance amount. So as I reduce the resistance amount, it's getting easier for things to flow outwards, basically. We can also do, I can offset this cost. So if I subtract the frame, then we can animate things, and basically this is the kind of motion that that it would provide on the surface if we converted this to a velocity like I was trying to do with the other input. So we could use this to create a force that's moving in these directions. I'm also going to try another node. So if we do distance along geometry, we can do the same thing here with our start point is 0, and our output attribute, we can just have it be the same thing with cost. So this guy is kind of doing the same thing, but we don't have the ability to supply a resistance attribute. So what I can do instead is, because this is just looking at the distance along the surface, like kind of the edge length, you can actually set it to edge length, but surface is a little bit more precise. But you could kind of think of it like very similar to edge length. So if I do a transform right here, what I can do is boost the elevation. So this is going to make it think that the surface is a lot longer or further to travel than if it was closer to being flat. And then if I don't want to have the final result behave like that, I'll do a rest. And then this will make a copy of the current point position. And then if I just do swap, then after it performs that distance, I can move my rest attribute back into the position. So basically, I'm duplicating my point position into this rest attribute, then scaling my y height to be taller, recording the distance along the geometry as everything is super stretched out, and then just replacing back the original point position, but recording the attribute. So this way I'm able to control things like kind of the resistance, but I can just choose different heights to try to set how hard it is for things to move in a direction. You can do invert transform. The reason why I do rest and attribute swap is because I can start to add other operations. So if you do mountain, like I could do an additional distortion that isn't just a single like transform value, but definitely for the way that I'm doing things here, you can do the invert transformation. Some things that I also do, I don't know if everyone knows about this, but it's a pretty handy thing, is at the bottom here, if you output, you record basically the operation that you're doing here as an attribute. That attribute happens to be a matrix that gets stored as a detail attribute. Then afterwards you can just do transform by attribute. And then you can do invert. So that's another way too of doing invert transform. So you could also do it like this, and then if I did a like reference copy, like that. So it's all a bunch of different ways to kind of do the same thing. But I usually will do things this way if I can, just so I could do additional distortions that aren't purely just a single like translation scale operation. Maybe a little bit slower, but I don't think it's noticeably like too bad. So now I have some areas that are harder to traverse than others. So, I don't know. I'm still figuring out my. So he's asking if I normally finish one effect in one stream. Or I guess it's. I'm assuming it's a he. Is that correct? Give me your pronoun. But yeah, I tried to. Okay, yeah. So I tried to do. I don't think I'm gonna finish this one today, but either tomorrow or Monday I'll get through it. But I'm still figuring things out a little bit. I think if I tried to limit things to one effect per stream, then I would be maybe a little bit limited in terms of the actual things that I can produce. Like they would all look a little generic maybe. So what I'm trying to do today is basically get our forces set up and maybe start with fluid simulations. I think we'll have time to get started with fluid simulations. And then keep going with that stuff tomorrow. So usually I try to aim for somewhere around 2 hours, 1 to 2 hours for my streams. And I think just with Houdini and all of that stuff, it's a little bit I did name this the Houdini speed run, but I don't know if I'm that fast. So I'm just going to reuse that attribute swap. So I also try to take time out to explain things or different methods, which also slows things down a little bit. But trying to do stuff as kind of an educational service as well, instead of just like showing off. So one thing you can do if you're visualizing stuff using this sine wave, you can also create ISO lines out of this pretty quickly. So reusing this swap that we were doing earlier, I'm just exchanging my point position with the color attribute. So it looks like everything disappeared, but basically all of the values that were white or above 1 are up here, and all of the values that were black or below 0 are over here. And then if I do a clip, oh, I got tricked. He got me. So that's one of the frustrating things with these new nodes. Sometimes when you put them down, it doesn't connect. So if I do a clip, then I can eliminate like basically all of the black points or all of the white points. So when I'm running the sine function, these numbers go below 0. So these go down to -1. So now I can put my color information back into the position attribute. And you can see we've gotten rid of the black points. And then if I just do another node, I can do a divide and remove the shared edges. So that will just keep the border points. And then if you do an ends node, then you can do unroll. And then I still have information here, but it's just hidden because of the color. So now we can get pretty cool ISO lines or kind of contour lines. And these will animate the same way that we're animating those sine waves. So it's a little bit slow of an operation, but these would like radially expand outwards. So this is a little bit besides the goal of the stream, but it's just a cool trick. So I can even increase, if I multiply my cost attribute, this is kind of like increasing a noise frequency, basically increasing the frequency of a procedural texture. And then that result will show in my my ISO lines. So this is a pretty cool thing. It works a little bit differently than doing just pure elevation-based ISO lines, because we are basically we're calculating that cost attribute using this distance along geometry. So if I just change this number right here, still cooking, but you should be able to see the result. So I'm gonna say maybe I want that to be a smaller value. It's a pretty cool thing for motion graphics or other kind of design based things. Just making like stylized terrain visualizations. So maybe this could be a good good starting point for our force. So if I do that poly frame again, I'm gonna do it based on the color, but I just want it to use the cost value. And then I can do it based off of attribute gradient. Okay, so I just need to type in the color. So basically this will tell me which direction those that color or that cost attribute is increasing in. So if I just do scatter, maybe I want to, the gradient, attribute gradient operation, it will end up assigning the output variable as a vertex attribute. So I set this to velocity, and then I just want to move that attribute from vertex to a point attribute. And then when I visualize things here, so I might need to do another operation just to make that velocity a bigger number. Now you can see that they're heading in their respective directions. So basically these are a bunch of different ways that we could use to push things outwards. We could use these trails and get that kind of force by using the velocity attributes that's stored on these particles. We could use these these values here that are on these particles. I don't know why this need to be a tangent. Yeah, I think that the tangent is the vector that I need to use. But either of these might work. So I might start with let's start with the particles for right now. So sometimes if you're prototyping a new effect, it makes sense to just through trial and error see what works best for you. So we could do another DOP network. This one's going to start to be our pyro simulation. I'm just going to save the Houdini file just in case we crash or whatever. So this is the 30th. All right. And then I usually work in a scenes directory. So all of my HIP files I put inside of a scenes directory. So this will be terrain, Shockwave, just call it version 1. So I think I know I'm going to still want to use that height field as a collision. So I'll plug that into that input. And then this first input I'll use again for the forces, or just the like source emission geometry. So I'm going to want to emit from these particles. This trail stuff over here is just a visualization, so I don't need that stuff right now. And maybe the particle solver adds a bunch of extra attributes like air resistance, force, etc. So I don't need those. I can do another rename. And maybe with this one, I'll just choose what to keep. So I want to keep velocity and the IDs, and that's pretty much all that I need to know for right now. I think we should be good. The other thing we probably want is p-scale. So p-scale is just the default Houdini attribute for particle size. It stands for particle scale. If you want to visualize it, if you just press the D key, you change to disks over here. And then that radius of that disk will be equal to whatever your p-scale value is. It's a quick way to do that. So you should be good to go. And then the last thing that I do, so this I'm going to do a smoke solver, smoke simulation inside of this DOP network. So the thing that I usually do with the last input is use a box to specify the size of my domain, my simulation domain. So something like that should be good for us to get started with. I like to do that to, again, keep things somewhat procedural. I'm not going to cache the particles. I'm lazy. I don't like to. If you're doing a big effect, I would say with many more of these, like 1 million, is a good idea to cache particles, but just for the sake of the stream or whatever working quickly, I'm not going to cache them right now. So we could go in here and make our smoke. We'll do a smoke solver, and to grab the information from our domain, we can just do the B box and the op input path again. And then we want to use 3, so that would be the last input of our parent node. So we do that, and then that would give us the X size. We can do the same thing for Y, and the same thing for Z. So I'm just using tab to move through those fields. And then instead of bbox, we can just use the centroid function to get the center in case that box moves around. So the center of X happens to be 0, but for Y, because we move things up, this will be above 0. So there we go. Then we need a smoke solver. I usually use this instead of the pyro solver, just for like simplicity reasons. If you go and double click inside of the pyro solver, you'll see that everything's being driven by a smoke solver, but they've just bundled some extra forces and micro solvers or whatever you want to call them. So it just becomes more parameters up here. So I usually like to work with the simplified one. If I want to, I can add those same forces up here to replicate whatever features I need from it. And then up here on creation, I usually do solve on creation frame. I should be, I don't know why I'm not seeing anything yet. Usually I turn all those off to get started. So usually when you middle mouse button, it will tell you like should tell you the simulation resolution, like the voxel size. Maybe I don't get it yet, but we can keep going. So I can do to get those particles into my simulation, I can just do a SOP solver. And usually you use this, like you put nodes and stuff inside of it. But I can just do use external SOP, and then do that op input path expression again. We want to get the input of the parent of this node, not the actual node itself, but the container that this node is inside of. And then that's 0 because I plugged my particles into that input. So you could do maybe pre-solve is a good one to use. Now you see that we have our particles getting pulled into the simulation. So if I turn that off, we don't see them. We turn it on, we can see them. And then if I want my particles to become smoke or to actually change my smoke simulation, you can do particle to field. So when this guy pulls the particles in, it puts them under this geometry name, and then this guy is automatically set up to look for them in that area. And then if I want to add my particles to the density, usually I turn off this extrapolated. Instead of copy, usually I'll do add, and maybe I don't need to use an attribute. So something is happening, but it's not right. So our simulation is such a low resolution that it's not, these are the actual voxels basically that we're seeing. That's what's, you call it a coarse simulation or a coarse domain. Basically it's too too boxy, doesn't have enough fidelity to store meaningful results. So we can just go up here to our division size, reduce that by a factor of 10. So now we're up to something a little bit more sensible. If I hide the results of that node, then you can see we're actually creating density wherever the particles are every single frame. And it looks like what we're expecting it to look like. That's very useful. I can make a copy of this if I just hold down the Alt button, drag it, shake it loose, like a game. Do you guys ever play Bop It? It just yells commands at you for operations for you to do. So we can do another destination field of vel for velocity. This time we do want to use an attribute which will be v. So we'll take v for particle velocity and put it into the field vel. So with Houdini they differentiate those. It's the same information, but it's just different names for it. So now when we do things, you can see we're actually inheriting the motion from the particles. So this is a pretty quick way to basically do what I was talking about earlier. We spent a bunch of time, too much time probably in some of your minds, messing around with particles, but you can see it all kind of pays off, because now we're able to very easily transfer that motion into a smoke simulation. So usually when I see people like starting Houdini, they said do a smoke simulation, they start with the smoke solver, they start making a bunch of volumes with forces, and maybe spend days trying to do something. But I like to spend a lot more time working with particles, shaping directions that I want things to move in, and then move into here and work this way. So it's pretty slow to play and read things back, even at that lower quality or lower resolution simulation. Let me just take a look at this. I don't know why I can't get that to go on the creation frame. It doesn't make sense. But if I want all of this stuff to happen a little bit faster, what I can do is switch over to, you're saying if I turn that off? I think it's the same. So what I'm trying to do is I want everything to get created, like I'm trying to get it to show my domain information even on the first frame. So you'll see right now it doesn't do that, but if I go to this frame, now I can see it's actually created all of the smokes, pressure, velocity, density, and all of that stuff. So I was just trying to, usually you can do like solve on creation frame, and then you'll see all of that stuff pop up. That's why I was messing around with that. So if I go up here, I'm just going to, like, usually, yeah, it will just shift everything by one frame earlier, kind of. So everything's starting, it will try to create results even on frame number 1 instead of waiting one frame, like delay. So I'm going to turn off cache simulation. And then I'm going to move this one over here to OpenCL. So that will tell it to use my GPU to do the smoke simulation. And then if I go up to this level again, I can just tell it to grab the density. Then if I go forward one frame, then you can see it has density. And then I'm just going to do convert VDB. So this is just going to take the Houdini volume, make it into a sparse VDB, and then that will just make it quicker for my display, my graphics card to display things, because it's like less information to try to display a sparse volume. You can see it's going to less voxels now instead of 200, 100, 200, or 499 kilobytes. It's down maybe a little bit less kilobytes, but less voxels and everything like that. Sometimes I'll do this primitive SOP as well. And this is just a quick way to change the thickness that you're viewing the smoke in. Whoops. And then just so things actually get some lighting information, usually I'll go up and make a light somewhere in my scene. So that will just help you evaluate the thickness of the smoke a little bit. And then I usually do this D key for display options, and I'll turn off limit resolution. So that will make my viewport display my simulation at its native resolution instead of clamping it at a lower resolution. Then I'll just pin the viewport so I stay up here at these settings. So I'm not using the sparse solver because it doesn't have this OpenCL option, unfortunately. So I find that even though the sparse solver is set up in a manner that you don't need to work in a square domain, using this on a OpenCL, it's pretty fast to get somewhat good results. And then you're also able to create, like, you can add forces in this empty area and you can have interesting things. The sparse solver, because it's not simulating the empty area, like sometimes it's kind of like simulating stuff in a vacuum. So if I wanted a gust of wind to be blowing stuff, like, it would be harder to create some other forces, if that makes sense. So this might be too thick just for density or for display purposes. And then let's see. If I want to, I could just gonna hold down the control button and click on that to visualize my terrain. Maybe with my spotlight, just make it a little bit bigger so it's illuminating everything. And then my domain, I can make that bigger to fit everything. It's gonna make things slower. But we either need to do that or reduce the resolution to compensate. But this should be good to get started. I might also reduce this particle scale or P scale so that they're creating less density, or the forces and stuff like that they're adding to the simulation are a little bit less every frame. And then I'm going to do a preview of this, so we could just do a flip book. So it looks like with the lighting, maybe I do want that to be a little bit darker just so I can make out what's going on. Usually I'll try to set up this viewport to be pretty close to a acceptable, like, final result. If I just need to show people or just to record my progress, like something that you could present as a render or something like that. So you're asking if the smoke solver has like the gas resize fluid dynamic. I tend to try not to use that. So with OpenCL, the GPU simulation, it doesn't really seem to speed things up that much doing the gas resize fluid dynamic. So that's why I don't worry about it. And if I want to look at my GPU usage, I'll do this command, NVIDIA-SMI. It's like a performance monitor for OpenCL or GPU usage. So I can just see how much of the memory, the total GPU memory I'm using. And then this percentage is like the clock speed, or how much of the cores I'm using. So you can see we're kind of getting like a reverse avalanche effect almost, which is somewhat cool. It's kind of what I'm after. It looks like overall maybe my velocity information isn't pushing stuff out as much as I want. So maybe I need to boost the velocity amount. And then also I might just want to make sure that my collisions are being used. So I think the gas solver will support this. Just do a merge. This guy, instead of input path 0, I just want that to be 1. And then maybe I didn't want to do that. So I think maybe some of this stuff might be. Let's just leave it like that for right now. So I just want my velocities, source velocity, to be scaled up by 5. So we'll try another flipbook with this additional scale setting. So things should be getting pushed outwards more quickly. And then I believe that this height field is being used properly as a collision source now. So I think in the previous simulation, maybe the velocity was escaping through that. That's why things were like turning into eggs a little bit and moving upwards. But now the terrain should be properly like reflecting my my velocity to move everything with it, basically. So talking more about that gas resize fluid dynamic, I tend to also have problems just with that node in general. Like there's the delay frames parameter on it, so sometimes it won't resize fast enough and the source will move beyond my current domain. So it will cause artifacts based on that. If I'm adding like a velocity force that I want in front of my particles, it won't resize enough to grab that. So just in terms of troubleshooting, it tends to make things more cumbersome, I guess, to debug. And then because I'm running everything on OpenCL or with the GPU, basically your simulation either fits on your graphics card or it doesn't. And then the size of the domain, the actual resolution of the domain doesn't change the performance that much. It's just if it's too big or not, if that makes sense. So if you're resizing things continuously, sometimes you might expand your domain too much and crash your simulation on the GPU in the middle of it. That's just another frustrating like debugging thing, if that makes sense. Yeah, these gas particle to field nodes, the radius of the particles that they get stamped or turned into smoke, that's based off of the p-scale attribute. So there's different ways to get rid of these kind of blobular types of shapes. One thing I can do, there's like a lot of different options I have. One thing I can do is maybe make another field instead of density that's temperature with negative buoyancy. So all of those things will fall down and move outwards. That would be more natural, I guess. There's also other forces you can do, like disturbance, turbulence, or vortex confinement that try to enhance the detail, basically. But essentially, you see these big shapes that happen because it's a bunch of velocity moving in one direction. So the best way to eliminate them is to add some randomness kind of to break up, so they aren't all uniformly pushing in one direction. You can also like push things against it, if that makes sense. So I'm going to go up here and set my division size a little bit higher, just so that we're able to move along with things quicker and evaluate like the decisions that we're making. So it looks like there's no checkbox or anything on this node, but basically these nodes use the p-scale value to choose the particle's size. And then they have this threshold parameter that's kind of like a blend amount. So if you set this to 0, the full value of the particle gets used everywhere. If you set it to 1, then it's kind of like a fall off from the center of the particle to the edge that will make the value that it's being stamped in like more intense to less intense, basically. So if you want to really test these out, I would suggest just making a simple file where you're just visualizing these things without all the other stuff going on, and you can get a better idea of the parameters. So let's try maybe, I'm just going to try moving this stuff up a little bit. So that it has like a little bit of padding above the terrain. So if you do the pop network, that doesn't use a particle scale or anything like that, and it will put these particles precisely so that they lay exactly on top of the surface. But now that we're treating them like they have a radius, I'm just going to move them up a little bit so that they aren't laying directly on top of the terrain. I'm also just going to shrink down my domain size so that we can again work a little bit more quickly. Whoops, I lost my terrain. So this is another reason I like to set up this using expressions, so that I can automatically resize things to crop the domain if I need to. So let's see what happens. Whoops. Nothing. So let's see what happens with those changed settings. I think maybe moving my particles up is helping to keep like velocities generally going outwards. I think another problem with the big bulbs getting left behind was that because things were laying directly on the surface, I was missing some velocity information. So does that make sense? just adding that little bit of spacing for the particle scale or particle radius, so that it's spheres like they're rolling along the surface instead of intersecting or swimming through the edge of it. Then we can make another field with these guys. Thank you, Julian. It's good to see you again. Yes, I'm basically just trying to do like a Shockwave style simulation, but kind of applied to a mountain. So instead of like a flat plane, I kind of want like this burst to happen. I don't know what it's going to look like. It might be like a reverse avalanche. I might do more of a stylized like paint mixing kind of look with it, but we're just seeing what happens right now. So I'm doing another gas particle to field, and this time instead of density, I'm going to go into temperature. So instead of copying particles to the density field or sourcing them into density, now I'm sourcing them into temperature. And then if I go to my smoke solver, for buoyancy, I can create a force based on that temperature field. And by default, it's going to try to make the heat rise, or the high temperature areas get this upward direction. But I can reverse that using -1. So that should be kind of like dry ice or something like that. So if we play things again, I'm just trying to get rid of those bigger things that kind of expand upwards. So with this negative buoyancy, things should lay pretty low basically. You can see now, instead of shooting up like that. Hi Jack, how's it going? Now instead of things flying up like that, we're able to kind of keep them at a somewhat low profile. So this is more like a heavier dust or a heavier snow, if this is a reverse avalanche or something like that. So it's a nice way of, I don't know, kind of representing something like that. I'm good, Jack. You having a good weekend? So that's what we're able to do with the temperature, which is pretty nice. We don't want it as strong. We can just change the scale of things like that. You also have temperature diffusion and cooling rate. So you can, with the cooling rate, you can reduce that temperature field over time. Which kind of, it's a self-explanatory parameter. Diffusion just does a blur on it over time. But I think that's okay. So now if we want to try to break up those bigger shapes even further, we can try to just add some other forces to kind of break them up. So if we have all these particles that are moving out like this, one thing that we can do is just time shift stuff. So I'm going to use this to offset the time. We're just going to go with the current floating frame, but move that forward 3 frames. This is like fast forwarding or advancing 3 frames ahead. And then I'm going to just do a wrangle. I'm going to do p-scale multiplied by 0.25. So a quarter of the size. And then the velocity Let's try multiplying that by -2, -1. So my idea with this is that we have our big kind of source particles moving, and then we have our little smaller particles always slightly in front of them, but going the other way to kind of add some disturbance. I can also do an attribute randomize, and I want to randomize velocity, but I want to do it direction, and then instead of setting the value, just add to the value. So that will just distort things a little bit, and again, just maybe not apply as much randomness to it. And then if I want that to be a different result each time step, or each time, I can just make sure with that. So if we merge these, now we have two things happening. We have our main guys, the big ones that are shooting things in that direction, and then we have the smaller ones that are slightly in front of it that are going to blow things in the other direction. Then the last thing that I need to do is maybe just make a group for these, because I only want these to affect velocity. I don't want them to affect the density or the temperature. So if I do a point group, maybe I'll just call these force, and then I can leave everything the same. So now we have 20,000 points total, but only half of them, or this stream, are in that force point group. So we go into velocity for particle group. Then I can do this as force. Let me see if that's... Thank you. Yeah, this is a good way to source things. The version of Houdini is in my Twitch panels. If you scroll down, it's under computer specs. But it's 18.0.416. And then all the other specs and the necessary information is in that Twitch panel. So I think this force, I'm kind of rethinking this. I don't want to use it like that. Because I want all of the particles to go into velocity. So I might need to try something like this. So that density and temperature are coming from everything that isn't in that force. I'm not sure if this will work. It looks like I have warning flags there, so it's not working. So I'm gonna rethink things a little bit. I'm not gonna do this force. What I'm gonna do is just make another attribute over here. This is a little bit clearer. And then this one, I'm gonna make density equal to 1 and temperature. Whoops. Can't spell today. So now we have temperatures and density, and when I merge things together, the particles from this input will have temperature and density of 0. And then I can just go in here and set these to use this, to look for the same attribute on the particles. So things should be a little bit more clear, I believe. And you also have control over this now because you could set these to other values that aren't 1. Like I could make at maybe the start of my simulation, those values are really high, thick smoke, and then it decreases over time or something like that. See what happens. So with my nodes and with my general Houdini user interface, Jack, I've just gone in and changed a lot of the default settings. I didn't like some of the newer stuff that was too round, so I changed it back. So overall, I'm using a different color scheme that's like a different kind of style of gray that reduces some of the shading. And then I think if you just do like preferences, network editor, I've done some things here. Like I turned off animation for network changes. I did simplify shape when node shape's off. Under view, display options, if you go to themes here for node default node shapes, I did no shapes theme, I think. And just some stuff like that. And then I turned off that node ring. I don't know, I tried to work in an interface that's like as minimal as possible. Even before with the older versions of Houdini, there was like a hack that you could do to make the node shapes like skinnier. So I don't know, I just like to tinker with things. So even with these older VOPs, I was setting things up to be like super goofy or whatever like that. But hopefully it's still easy for people to follow along. So it looked like my idea to blow things back in the other direction still wasn't working that well. So instead of going super small, I'll make that a little bit bigger. We should be good to go. Maybe I'll reduce that division size down a little bit. Let's give this a try. You guys end up customizing your settings that much, or you usually just go with the... I guess people starting the software more recently, they'll just start with what's given, but the boomers, the old timers, will always just want to revert to what they know a little bit. You guys want to talk about boomers using Houdini? So it looks like I'm getting a little bit of more breakup. Let me try something else here. So I'm going to do a point replicate. Oh no. Didn't like that. So get back to where we were in a second. What is the this guy? Is Houdini crashed? Why? So looks like we're back in working order. So with this point replicate, I think I just need to get my display flags set up. That guy should be showing. maybe I just needed to do it a second time. So with this point replicate, what I'm trying to do is make more points basically. So it will create 10 points from the original one. Maybe I just want to start with 4. And then I can do, this is like, let me, so I need to make sure with attributes it's copying the source attributes like p-scale and stuff like that. And then using this uniform scale, this gets adjusted by the incoming p-scale, but this allows you to, when you're replicating the points, they're offset from their original position a little bit. And then I want this to be different every frame. Maybe even bigger. So in front of our original points, we're going to have this cloud of points kind of blowing back in the other direction. All right. Do you like more colors, Kieran? I was doing that for a little bit, but I found it to just get a little bit confusing sometimes. And then whenever I picked up a file from someone else that wasn't using the same colors, I was getting OCD and just wanting to recolor their nodes to be the same thing. How long have I been using Houdini? I don't remember the year, but it was since Houdini version 11. It might have been 2012 or something like that, maybe. For 8 years, I guess. So it looks like we're starting to add some detail to that stuff, but it's still not working as well as I want it to. I'm going to try to increase this size a little bit, like the amount of randomness to those. Maybe I want this. Let me just try scaling the velocity to 6. So these guys should really be shooting back in the other direction. Let's see what happens here. I lost my my template flag and all of that stuff. All right. I'm in San Francisco area. So like I was saying, you guys want to talk about boomers using Houdini. I think I have something here. See this? This is actually an instruction manual. Maybe before the era of the internet. So you see the date on this? We're 1999, Houdini 4.0. So it looks like my noise breakup is looking a little bit better. But this is super, I don't know, like I can't imagine trying to learn Houdini then, but it's super interesting going back in it and seeing like they still had Vex code, like Vex programming back then. So like you could still find that people were like what features were in Houdini or whatever. But yeah, it was so this is definitely an artifact. This super stylized guy. So you could even it was like an old Houdini logo. you go into a new Houdini scene, you can still find that old logo. I think it's like an Easter egg kind of. So you guys see what I'm doing with that extra, those particles that are blowing back. So we're able to shoot things back the other direction a little bit. So I might need some more using that point replicate, because it might be some areas that are missing or something like that. So the loading screen, and there's another thing that I customized. So with the file, if you go into, instead of $hip, $HFS, that stands for Houdini file system. It's like your Houdini install directory. And then if you go into the Houdini directory within that, and then geometry, this is like default geometry or whatever that comes with the scenes. But this, you can find that they still have that old, this is like that, it matches the old logo from their old branding or whatever. All right, so let's try some other things out to try to mess around with this. I don't know if we'll get all the way through this simulation today. We might have to keep going with it tomorrow. I realize that this stream is already getting pretty long. We'll see. We'll spend a little bit more time on it right now. Yeah, so that was one thing I was going to adjust. Kieran, you had a good idea. My buoyancy is a little bit too much. This cooling rate, this will reduce the temperature over time. So right now, previously I had everything zeroed out, and this temperature was always prevalent. So it was just causing this pool in the middle. With my cooling rate at 0.675, it should gradually eliminate or take temperature out of the simulation over time. And then I might just want some more point replicate. I might just want some more of these particles. So let's give this a try. I'll be right back. So it looks like maybe we have too many of these guys going the other way. Yeah, I usually put the hip on Discord, the working files. If you guys join the Discord in the Twitch panels, there's an invitation link to it. So it's a good place to you're working in progress on things. You can share screenshots or animations. This stream archive, I'll put a Google Drive link, and then I'll put a link to the VOD or the Twitch video on demand. So I think my velocity vectors that are pointing the other direction are too much. So it's another reason that's causing all of that pull up. to happen. So we could reduce that magnitude of them. Instead of -6, let's try -3. And then also reducing the scale of them will additionally reduce the overall magnitude. It takes some time to think about it or whatever, but basically, if you have a bigger particle, a bigger area of directional velocity, it pushes things further than a smaller area with the same value. So we might have overcompensated a little bit. We will see. Let's try maybe just -5. Maybe, yeah, -5. And then this randomness, I'm just gonna double that, or a little bit more than double, and go up to 2. So my thought process is we can still have a big force pushing things back, but with the additional randomness, we'll just kind of break things up a little bit more. Yeah, so I'm in San Francisco. Usually I try to do these like West Coast time, Pacific time, 1 p.m. But I realize you guys are probably all over the place, but 1 p.m. is hopefully still like a good time for Europe, UK, all over. Maybe like Japan, it might be the middle of the night there. Are you in Japan, Kieran? This your last name sounds kind of Japanese. Oh, Sri Lanka. Yes, I guess you get too far west in the I guess I don't know, European continent. I don't know my continents, but yeah, I guess it does get a little bit too late. But maybe your work schedule, you're up late, or other people can watch the videos on demand. So you're asking about making the smoke diffuse with the height. You can do something like that. I want to try to avoid it a little bit. My overall density, I've kind of overcranked things just to visualize stuff a little bit more. So I'm visualizing stuff just as very thick smoke. So you can diffuse the density, or that's just kind of like blurring it over time. You can also just fade it out, like decrease it. Sometimes also what I do is, instead of just density, I'll just pull in the temperature field, because that one already has built-in controls to do cooling. So before I start with blurring things like that, I'll just try doing more of a cooling operation, which is just reducing the amount overall. Because anytime you are actually doing like a diffusion operation, is a smoothing operation that will reduce detail. So I did a couple operations there between these two results. One thing that I did was reduce the visualization density overall of the smoke, and then I switched the field that we were visualizing from density to temperature. So that's something that will essentially just fade out over time. So it looks okay. I'm gonna still play around with some of this stuff. I'm gonna have these guys go 7 frames forward or 7 frames ahead of time. Just so that they have more, they'll be further in front of things, and that velocity will have more time to have an effect on things. Basically, there'll be a bigger gap in between them. Going to make more of the points overall. Just give that a try and see what happens. So if you scrub between the cached frames and the new frames, basically, that's a quick way of kind of seeing the difference. So it looks like I am able to kind of pull some smoke off of those bigger eggs, or the bulbs, or whatever you want to call them. So we're definitely making improvements. There's still other things I'd like to adjust and change. But we're heading maybe somewhat in the right direction. I'm gonna make some more changes. So let's take the velocity here and multiply it by, whoa, that's a big tooltip. Multiply it by 1 for x. What did I want to do? -1 for y and 1 for z. So what I'm trying to do here is instead of having the y point up for those particles, I just want to flip it down the other way. If we look at some of these here, you can kind of see what's going on. I don't want to move the camera to zoom in because I want to keep it in the same place, so that when I do another simulation, we can still just scrub back and forth to visualize, to keep everything 1-to-1. The VRAM, I think it's 48 gigabytes. Something like 48. I'm only using around 12 or something like that right now. And then this Houdini, other software is using other things, like this Houdini's maybe only using 1 or 2 gigabytes or something like that. But I do a lot of smoke simulations and stuff. The Redshift is okay. The VRAM to me is the most important because I do most of my smoke simulations with OpenCL, so I don't want to run out of VRAM for that, because then you can't run it on. It either works or it doesn't work, basically. So now you can see the difference with flipping that velocity around. Just from going up to down. Yeah, 128 of CPU RAM, but if you're or not necessarily CPU RAM, but just like system RAM. But with OpenCL, it doesn't use any of that normal RAM. It will only use the VRAM, which is why I'm trying to have so much of it. So this is maybe a little bit better. Maybe I can just multiply this by, instead of -1, we'll do -0.5. So not only will it flip it from up to down, but it will also reduce the magnitude only in the y component, but it will reduce the magnitude by half. So our simulation, yeah, my IMDb, or I didn't do a good job linking my CV, curricula vitae, or resume or whatever, but I'm going to increase the resolution of this. Yes, I used to work at ILM, also DreamWorks, when they had an office that was in this San Francisco area. That's actually at DreamWorks, that's where I got that really old instruction manual for Houdini. So what I did there was increase the total resolution of the simulation by quite a bit. So it's going to play back. I might have done too much. It'll play back slower. I'm just trying to see how much of that blobbiness was from a low resolution smoke simulation, and basically how much of those blobs, or the eggs, that we can get rid of by working at a higher resolution. So we're doing maybe a frame now every like 10 seconds, which is a little bit too slow for how fast I like to work for smoke simulations. Basically, like, as your frames per second or frames per 10 seconds for smoke simulations gets longer, then every time I make a change, it's going to take me an hour or something like that now. So that's just a little bit too slow for doing a live stream, or just even if I was working by myself, I wouldn't try to have things going that slowly. So now we're kind of at a happy medium. I kind of split the difference between the two. Our original low resolution, that one that was maybe, that one was like a final production that I just up-res to. So I split the difference, and now we're at more of a, I don't know what you would call it, like high quality. So this is maybe 2 or 3 seconds per frame, which is a good speed to be working at. So as we go higher in resolution, we're able to evaluate those particles on a denser grid, basically, or just the particles become less blobs because we have more resolution to kind of rasterize them into. Final quality. Yeah, so it's you just keep adding those names instead of versioning up. Usually I'll end up with some pretty funky version names. It's like version 2.378 or something like that. It's like I'll go back and just make a render, tweak, rename. Just bad habits. So you can see we're getting a little bit more detail by just increasing the resolution. A lazy way to get more detail, but it works. Another thing that I'll do sometimes is go into the solver under advanced, change this to a higher order advection method. Change my advection type from modified McCormick to this forward backward BFECC. And usually this blend, I make it like a really small value. This doesn't hurt you at all, but it can save you from getting some grid kind of linear axis aligned artifacts in some situations. And then this higher order advection model, RK3, it's very hard to explain technically what it's doing, but it's kind of like using if you know about like interpolation functions for splines or stuff like that, like you have linear, Bezier, bicubic, all of those operations. It's kind of like a more it's a better interpolation method. Not necessarily interpolation method, but it gives you a similar result. Because if you're working on the CPU, those settings that I did will make the, I didn't make the solver. I've just read books about them and stuff like that. So, I don't know where I put it. I'm trying to look at my bookshelf right now. Yeah, so this one here, the fluid simulation for computer graphics, this guy, Robert Bridson or Robert Bridson, this one is a pretty good one to just look at if you want like an overview of smoke solvers. It does have like a lot of those mathematical like Greek letter equations, but you could still just skip over them if you can't read, like I can't really understand them. And the book will still make sense to you. And then that guy that wrote it, Robert Bridson, he actually works, I believe he's working at Autodesk. And I think he's one of the guys that's helped to implement or write Naiad for them. Or I mean, not Naiad, but Bifrost, which he was originally working on Naiad, I think. So he's definitely a good author to look up and research or whatever. I think he's done some behind the scenes stuff or whatever. But that's a pretty good book if you want to know. It's a big time commitment or whatever, but if you're really interested in understanding like everything that's going on with fluid simulations, it's definitely a helpful book to read. So it looks like we are able to get some more detail, both with increasing the resolution and then increasing the quality of kind of our advection model and stuff like that. We're getting a little bit stuff, like kind of depends how chunky you kind of want to get or how billowy, but this kind of stuff is still, it's okay to me. I'm going for more of a cloudy kind of effect, or I might just use these, yeah, I think that guy, he was one of the guys that wrote one of the first like kind of CG fluid solvers, I think. I think he was a big Stanford guy too. Like he was so Stanford had something that was called FizzBAM. There was like their physics stuff. I think he was one of the big guys behind that. Maybe not, but I think his big paper was the one that's called Stable Fluids. And this paper is basically like the white paper, or like reading this paper and then implementing it, you basically end up with the smoke solver in Houdini. But at the time, this was a pretty groundbreaking thing or whatever. I don't remember the date of this. It might have been sometime in the 90s or something like that. But yeah, he's a pretty, what is this? Yeah, I haven't read this one, but it's definitely a good one to have. So yeah, things are looking pretty good. There's a bunch of other changes I'm thinking of making, but I'm not sure how many I'm going to try to put in today or right now. This might be a good stopping point, I think, actually. So I've been going for like almost 3 hours. We've made good progress. We figured out a bunch of different ways that we could create those velocities. We even did some fun abstract visualization type stuff on the side, making the ISO lines or whatever, the contour lines. So if you guys want to still spend more time doing this type of stuff, you could play around with it. Tomorrow, I'll probably be going in and tweaking this stuff some more, starting at the same time, 1 p.m. Trying to push. Oof. I guess since I crashed, that resample is going to take another 1.5 minutes to cook or whatever. But yeah, so we've been going for some time. So I'll I'll put the hip file onto the Discord. 2.39 is that's how long this remesh is going to take to redo its operation. But that's how long I've been streaming, 2 hours and 39 minutes. So yeah, it's getting to be a little bit, doing Houdini and a lot of that powerful thought process is kind of taxing. I can't put up like the 10-hour stream numbers yet or anything like that. So I'll save this single file and I'll post it in the Discord. The link to the Discord is on my Twitch panel. And you guys can go through that, pick through it, and study it, come up with new ideas if you're going to come back tomorrow, and I'd love to hear them. So I'm going to send this channel to another guy who does it looks like he's doing Houdini right now. So if you want to keep going with that, it should be a fun weekend for you. All right, see you guys tomorrow.